Okay, audio check. 1, 2, 3. Sounds good to me. I think we're live. So, ladies and gentlemen, welcome to the Discourager of Hesitancy, where we are not today building a game with no game engine. Instead, it is compiler day. So we are fixing some more bugs we found with our Tokenizer Generator. Let's go take a look at that. Actually, I'm going to restart Emacs so we have a clean environment. We're going to resize our window. We're going to load up our project. All right, last week we fixed some encoding issues, so we're past that. Those encodings all work now. We support UTF-8, ASCII, and Latin 1, and we had that working mostly through the UTF-8 code paths, but we have fixed those other code paths for the other encodings, and they all work. The tests run, and we can go through all of them. It takes about, I don't remember, 3 or 5 minutes to build every combination we have so far. But in doing that, we have found that the lazy does not end well. So at the end of a text buffer with lazy token evaluation, we're not really doing a good job of wrapping that up. So we will have to do some testing and work around that. Yeah, lazy mode, lazy tokenization is our biggest problem right now. Yep, so this will be fun. Let's take a look here. In the old to-do list, we're going to take a look at both of these bugs. Let's see how far we get. Yeah, so we're getting along in our old Tokenizer Generator, slowly but surely getting there. Yeah. We still have some other loose ends we got to deal with. This one wouldn't be too hard. This one probably isn't too bad. Maybe. I don't know. This one is an interesting one. I don't know if I need that right now. But yeah, we're in the midst of this one, automating every combination of performance-defined flag. We're kind of in the throes of this. We kind of are doing that, except we have a couple of bugs. We also have to do the go-tos before I really consider that automated testing done. But overall, the Tokenizer Generator is somewhat usable in some states. So about most of our builds actually work. Just the lazy setting is breaking us right now. So I think that's the start of the task list for today. We'll see how far we get. We might as well take a look at what that looks like. As per, oh, come on. So it cleans VV, re-embeds all of our code snippets, compiles VV from scratch, and it runs the task. So it's building our Tokenizer Generator with these flags, and then runs it against an ASCII, a Latin 1, and a UTF-8 version. It actually builds the project 3 different times. And you can see until we hit lazy. Oh, wait, what? Oh, I know why. They're all passing. They're passing right now because we took the sample that works. So if it ends in a new line character, lazy works fine. So that's why that's currently working. We always say it's not. There's cases where it doesn't. Basically, anything that doesn't end in a new line character fails the tests. And for every one of these combinations, the build is very specific. And I forget, there's like 40 tests with 3 encodings each, so we're actually compiling this and running it 120 times. And every combination succeeds except for lazy processing, depending on what's at the end of the test, of the test text. So we'll let that run out. Then we'll set ourselves up to automatically build one valid setup that we can test against. Because the whole issue happens at the end of a compilation, or at the end of a tokenization, at the end of the file. So you can see we're using different file open methods. Sometimes we define things as macros, sometimes we define them as functions. Macros don't have the function call overhead, but then your code size increases, so maybe you're getting less instruction cache benefits. So we're going to eventually measure performance of all these different combinations and see what's the fastest. But we're not there yet. Okay, now that's 1, 2, 3, 4, 5. 5 dimensions, and then, of course, ASCII, Latin, UTF-8. That has a slightly different trade-off, right? We can process ASCII faster than UTF-8, and we can process Latin 1 faster than we can ASCII. They all behave differently. Like, you would use UTF-8 not because you want performance, but because you want more expressiveness. You want more tokens available. But it would be nice to know what the trade-off is. How much does it cost me when I use UTF-8? Is it at 10% to my tokenization time, or? Okay. So it works except for in certain circumstances. So let's do a little work here, actually. Else. Here's the else. Let's break this out into a couple of functions here. automated testing. We'll go from here to here. Boom. It gives me some more flexibility. Then this one, we can call it manual testing. Logging defines is like the least interesting part right now. So for automated testing, I can think of 4 conditions we want to test for in regards to how we exit at the end of our input buffer. I can think of 4 different things. 1, it ends in a new line character. New lines are special. That could be a /r or a /n, it doesn't matter. If it ends in white space, so if it ends in a valid token which we must discard, or a comment, right? Either one would be the same. If we end a comment or a white space, but we have to discard the token. If it ends in a valid token that we keep, that's another case. And then the last case, which is the second bug we looked at in the journal, is if we end in the middle of a token that's not valid yet. Yeah. So I can actually think of 4 different tests. So I actually want to break this out into 4 chunks. We're going to do automated test, and this will be ends with new line. Which is basically this. Let me think. Oh, let's see here. Two, three, four, five, six, 7, 8. So our longest token is this world. Number of tokens is 5. Number of lines is 3. Maybe we do this. We craft these strings in such a way that we can run the test here. Okay, so this is ends with new line. This is one set of strings we'll want to run against. Ends with discard, white space, or comment should both work the same. Ends with discarded token. So we'll get to that shortly. And ends with kept token. I don't really care what that token is. Ends with incomplete token in unacceptable state. So we basically want to run 4 tests. And the results we'll take a look at here. Okay, so if we want it to end in new lines, we don't have to change anything. If we want it to end in discarded, the simplest thing for us to do right now is to just add some white space. It should yield the same result. This one needs to end with a kept token. So we can do like a number. But then we have to remove this one to get the counts to come out right. Ends with an incomplete token. So this would be an incomplete string. Incomplete, let's see here. Add stir, and there's no closing quote. Except this test does not look the same as the other test, so we should comment that out. Is this a Boolean? If it has an error, pass, otherwise fail. Return has error. We want true if it doesn't have an error, if it's error-free. Maybe we pass in. Oh. Let's see here. Text and post char star label. Hey, Javest, long time no see from my side. How are you? I am good. Yeah, where you been, man? You've been hard at work, huh? Glad to see you popped back in. every error condition we want to indent. Pass or fail. That's the last thing. And then return. I guess you just had a move, right? So still unpacking, broke your internet. Hey, Sarah Carter, thanks for dropping in. Thanks for the chat. Thanks for the follow. How are you doing? My headphones aren't working right now. Can you chat instead? By the way, which games do you stream the most? Well, Sarah, welcome to the stream and thanks for the follow. I usually don't stream games. I write software. Monday through Thursday, build a game with no game engine and minimal dependencies. On Friday, we are doing compiler from scratch. I only stream games when I'm not feeling well. When I'm sick, which has only happened once, and I played The Witness. There we go. Okay, let's see here. Been really busy with the latest project. Today I submitted it for final assessment before going into production. Cool. It feels good, so now work will be a little less hectic for a few weeks. Awesome. Awesome possum. It feels good to ship a project. Glad to hear you're still alive and kicking. I was afraid you'd found a better streamer to watch or something. Shouldn't be too hard around here, but you know. No better streamers to watch. Oh, you're so sweet. Thanks. Very funny. All right. Treemosher thought your stream timer said 23 hours. Wow. That would be impressive. No, I've not done a 24-hour stream yet. I don't think I have enough viewers to justify that kind of effort. But you also are welcome to the stream and in the chat. Now, that's not to say I haven't done 24-hour coding sessions, just never on stream. I find that streaming makes me more tired, so... And I usually only save the 24-hour coding sessions for an emergency. Well, what brings you here today, Treemosher? You need a project rundown or just lurking? Up to you. I can give you all sorts of break-in. Okay. All right, so as far as I can tell, Sarah... So I gotta chat to Sarah because the headphones aren't working, I guess, but... Yeah, 24-hour stream. I don't know, what would it take for me to do a 24-hour stream? Just wanted to find someone streaming coding stuff. Gonna make you my coworker while I get through my Friday afternoon project. That sounds great. That's I think that's how most of my watchers are. They want a voice in the background. They want something they can kind of glance at once in a while and see what's going on, and just have something in the background. So feel free to lurk. I'll pull in a bunch of data for a project with a vendor. Okay, all right. Well, today is compiler day. We're still working on the Tokenizer Generator. We're doing it all wrong. Well, not wrong. I think it has value. Just to give you an idea. What's it called? Performance switches. There we go. So I'm building a Tokenizer Generator. Well, let's go to the scratch buffer. So normally you have a text file or code, which goes into a compiler. We'll try to make this somewhat legible, which then outputs an executable. Well, the compiler we're going to break into, right? So you go into a tokenizer, and out comes tokens, which are then fed into a parser, which outputs an AST, which then goes into semantic analysis tools, which then outputs basically a AST with more information, and it's error checked. And then I'm going to hand wave the rest of it, but out comes an executable, right? So this is the compiler. Well, let's see here. This goes out to code generation, optimization. There's a million things you can do. Optimization. Okay, so where we're at is actually somewhere else. We're at Tokenizer Generator, which can take in, let's see here, maybe the letter V. It takes in configuration and outputs a tokenizer. So we're writing the code that builds the Tokenizer Generator. For starters, let's see. Do I stream daily? Sarah Carter. Yes, I do. Every weekday. Glad you're enjoying it. Okay. So, this is the part we're actually working on. Is we're writing code to take in a configuration and generate our tokenizer. So our configuration looks something like this. Test.v tokenizer configuration. So we have the name of the token. So this will be a new line or a white space. And X means we discard. L means count up a new line character. And then here's the regular expression pattern for it. So this is just for testing, not for a specific language. We're just working the system. But here's how you would define a string. You'd say, here's a string, we want to keep this token, and it starts with a quote, ends with a quote, and there's a bunch of stuff in between, maybe. So this is the configuration that's fed in, which brings us to our performance switches. When I'm building this, I have ideas about performance, right? How do you open and read a file? Do I want to iterate using a real C++ defined iterator class, or do I just do the bookkeeping myself? How do I dispatch my DFA states? That sort of thing. And so instead of coding it one way, I'm coding it every way, which means we now have all these permutations of code paths to go through. And it's going to take a lot of testing to make sure that all those code paths work. Let's see here. I just took a break from work and your stream is coming in my suggestion, so I decided to join you and have some fun. Okay, Sarah. Thanks for joining. Appreciate a good active Okay. Otherwise, I just stream and talk and stream and talk. There we go. Stream of consciousness. While I do it. So yeah. So what we're writing right now is the tools test permutations. Is we have all these different permutations that we want to do. So I'm testing all of them in a script. That's what we're working on right now. All the different permutations. So if we go to our shell, you can see my previous output. So it's 20 different permutations with 3 different supported text encodings. And then we found some bugs last week. So that's what we're dealing with today. Let's see here. So Sarah wanted to know if streaming is my passion. Oh, maybe I should respond since it's ad fine. Whatever. Streaming isn't really my passion. Coding is. But I think there aren't many long-form programming streams, so hopefully people can learn while I work. Yeah, so here we are writing code. I guess I'll address that right. Yeah, so that's Sarah. As a content, so I don't really think of myself as a content creator, rather a programmer who happens to stream. Okay, so we found some bugs last time with our lazy process. So if we batch process, that means that we go into our tokenizer and we just sit there and grind until we have all the tokens gathered up. But the other alternative is lazy processing, where we generate a token when you ask for one. So in this chart, the tokenizer can pick out all the tokens at once, or you can pass the tokenizer itself to the parser, and the parser will say, oh, I'm ready for the next token. I'm ready for the next token. So we're coding it up both ways. We'll measure performance once everything's working and we have a sizable test case and see what's more efficient and how much it costs. So we're making no decisions. We're coding everything all at once. So this is bad. Don't do it. Also, tokenizer generators are not probably the best way to do things. Writing a tokenizer from hand is not that bad. Just a loop over each character. Writing a tokenizer generator is overkill probably, but it's for me to entertain myself and educate myself and learn a little bit more. NFAs, DFAs, these are kind of fun problems for me, so I don't really care if it's the wrong way. I'm just doing it for fun and education. So there you go. High level background done. Back to our testing. I'm going to do a couple of things here. Automated test. We're going to short all these other tests for now. And we're going to break out of this at some point. Oops. Oh, not this loop. We need to break out of the text permutations loop. Compile and run test, break. There we go. So we're just going to run one. We're just going to make sure we didn't break anything, and the outputs are about what we would expect. Okay. Oh, okay. Wait. I forgot. Ends with new line. We forgot the label. Tree Monster. Building things manually is a really helpful experience when you have to troubleshoot later too. Big fan. Oh, thanks. Yeah, we have no dependencies. We're doing it all from scratch. So all the UTF-8 handling, it's all from scratch. So just for fun, education. Also, I think people are too quick to pull in dependencies when you could just code it yourself, and then you end up with bloat and other people's bugs and what I call abstraction shear, where they've conceptualized the problem one way and I conceptualize the problem differently. And if I use their library, like I have to like write this weird glue code in the middle that kind of covers the two. So now that's not to say you don't use it professionally, right? When you're working, you do whatever you have to do to get the job done. But we are just coding for fun, so let's code it ourselves. Learned a lot that way. Okay, it still hates me. Let's go look at our log file. .log. All right, so we're going to run this command ourselves. argc was not declared. What? Oh. There we go. That was it. No problem. Okay, then we're gonna go tools / test permutations and come back. Let's see how that looks. Yeah, struggling with some Oracle behavior with Python's SQL alchemy, tempted to deconstruct someday. Yeah, I mean, again, education. Now, let's see here, Sarah Carter. Actually, with gaming, I also do some artwork for streamers, so I can make something cool for your channel. Okay. Well, ladies and gentlemen, the Discord server. I'll just throw it in the chat here for anybody that's interested. Feel free to join the Discord server. It's not very noisy. Mostly it's just a daily announcement when I go online, so you know when I'm on. So feel free to pop in. Yes. But yeah, if you have any questions, let me know. I'm happy to slow down, stop, sidetrack, talk about anything. Okay, so that works. So far I haven't broken anything. I'm going to swap lazy and batch. Because I would like to see a full correct execution. Without the break. or rather, testing, here's the label. That's why it's not logging the label here. Okay. All right. So I'm going to run this with a batch process. Just make sure it still runs. We didn't break anything. Check the log. Testing ends with new line, pass. Okay. So go to test.cpp. Let's uncomment these two. Because with batch processing, those should work. We should actually get 1, 2, 3 checks, but we'll only report the one pass. But my log file should contain more details. Nope. Okay, so let's see here. Redeclaration. Oh, that makes sense, actually. Okay, that makes sense. You just get rid of those. We'll be happy again. Automated test execution does need more text. Ends with discard. Ends with a keep. Ends with incomplete token. I'll know what I'm talking about when I see those. Okay, so that works. We can go back to testing and see what happens. I sent you a friend request. Can you accept it? Then I'll show you my work. Sure, sure, sure. Pending. There we go. Cool, cool. Nice handle. Okay. So this needs to run 3 times. It is taking a while. Oh, is it hanging forever? Shoot. Which one causes the forever hang? So like I said, there are issues at the end of our input buffer. Oops. It's the wrong window, but that's okay. Let's see. Okay, so we kill it. Bring up a new shell. We Need to turn one of these off. Test CPP. I don't remember. Actually, we nail the last character of the C journal for more details. Okay. 1108. If the last thing is not a new line, open-ended regex is spin forever. So the white space so maybe this one works. Unclear. Oops, let's see here. There we go. Okay. Actually, some of these aren't too bad. Cool. We got a decent number of people dropping in offering to do channel art, but all right, let me just do this real quick. Let me look back. There we go. Okay. All right. What was I doing? We were testing the kept token. All right, so tools /test permutations .py, and then we go up a directory. It may hang again. I don't remember. So here it does the build. Leaves the source directory, comes up to here and runs the executable. Or it just seems to be hanging again. Okay, well, kill our buffer. And starting over. All right. Okay, where are we? So I guess we do that. And we undo that. Okay. So we're going to test all our permutations again. Which should just pass, but we'll have to do some manual testing. Okay. So we need to do a manual test with a discarded token at the end. Let's do an ASCII. And then our ASCII, just make sure it works. fopen do that. Helper functions, process lazy. Let's not do lazy to start with. Let's just make sure we're back on for batch. Let's switch it in a minute. Switch is fine. Pointer bind is fine. Okay, now we're going to run the code ourselves. /source builds debug test parser. That should not be doing that. It should go into manual testing. Oh, maybe I need to clean and debug. Oh no, I need to clean and test. There we go. That's what I wanted to do. Build the test myself. Okay. None of those should be defined at all in this run. Yeah, that's not defined in here at all. So where is that coming from? Compilation. Confusion. That's not right. VB test parser. Huh. debug VB test parser. Let's remove all the builds. Doesn't exist, that's great. Compile. Building all of these .o's, but VV is not being built. VVEXE, right there. And it says it succeeded. Let's build debug. What is going on here? This has always worked before. Directory builds debug, or make the directory, then compile. Output to build/debug VVEXE. What on earth? I'm not getting any output at all. What is going on? Not building in the wrong directory. There are no .oauth files. What has happened to my build here? Turning 0, so it thinks it's doing it. Hmm. Hmm. This is a compile command, which should output to here. But it's not outputting anything, but it's also not outputting any errors. That is way too fast. What is going on out here? How can this compile command output actives? The execution was correct. So echo $0, $sign ? is 0. The output of that should be in builds debug vvexe, but it is not. What is going on here? It worked last week. Wow, okay. Find dot dash name vvexe. Is it getting put somewhere? Oh shoot. Is this Windows find instead of grep find? Okay, fine. We'll do this the old-fashioned way. Active projects. Source builds debug what? I'm also not getting any .o files. What is going on? Is my folder read-only? It made itself read-only? But then wouldn't the compile command fail because it didn't write the output? Is that the problem? Okay, why is this directory read-only? In theory, What is going on? Oh, I hate Windows. Hate. Come on. Okay. Windows folder marked read only. Oh, well, what about this? Is it the parent folder that's now magically read only? And why would it be? Who's deciding to read only that? I've never clicked a button that does that. I hate operating systems that try to take over. Is it this whole folder? Oh my gosh. Is it my whole drive? Check for file system errors. Did I lose access to my drive? Sorry, just doing some systems checks. I just updated Windows and rebooted yesterday. I should not be having disk issues where it becomes read-only for no reason. So we're scanning for drive errors, which Windows estimates for elapsed time is no errors were found. Oh, that's good. So if I go in here, why are they all marked as read only? Oh my goodness. Okay. I'm going to pop the drive. Which I think is this one. Oh no, that's this one. So in theory, I'm removing read-only from my entire directory. Why it's read-only? I don't know. But if I hit OK, bring up properties again, it says read-only again. Miserless hobo. ¿Por qué? Windows folder marked read-only and won't remove it. Your folders revert to read-only mode for various reasons, including restrictions imposed by your administrator. Not a problem. An issue with the recent Windows update. That I would blame, but it was working yesterday after the update. Or changes you made to Windows Defender or your antivirus settings, which I've not done. Do you use folder lock software to protect your data? No. Windows Defender Firewall, antivirus, forcibly remove the read-only. I just ran check disk. Let's see. Are all these other ones also read-only? Advanced? No. Properties, security. Group or usernames, authenticated users, administrators. Users. Wow, okay. Who's changing my security settings? Windows Goat, I hate Windows. We're so much smarter than everybody. We want to reset all your folders to have permissions that don't make any freaking sense. If that's even the issue, I do not want to have to reboot Windows Friday. I try to go months without rebooting, so why am I having to do it now? Properties, read only. It says it's read only again. Windows sucks. Yeah, but I removed all that stuff. So Godot, active projects, VV, source, CPP, HPP. There are no object files. I do not want to have to stop the stream to work. This was just working. We were running. There's something running on my task manager that shouldn't be. Browser, my Discord, Emacs. Microsoft Edge. I hate the fact that Microsoft Edge is running on my computer despite the fact that I've never started it. Click to run. Why is news and interests running? I have that disabled. It says it's suspended at least. OBS. Windows console host. Desktop window manager. Windows Explorer. Should we restart Windows Explorer? Maybe it's being stupid. Restart. Doesn't look like it made a difference, so that's always discouraging. Yeah, that went way too fast. There are no O files. It knows about the HPP files. There are no O files. My compiler is literally doing nothing. No input files. Okay. Why is it not outputting errors? Okay. Now this -c means we're outputting an object file for this header using these build flags. So I should have a .o in here now. There it is. List of objects. Pound defines. There's none. If I do this, still isn't one. What if we remove all the defines, which is not good. I shouldn't have to do this. Oh. I don't remember that being a thing. The fact that make. Okay, now it's taking time. There's a bunch of stuff. Builds debug. There it is. There it is. Okay. Sheesh. Okay. Small side detour. So either when did G++ get renamed to G++EXE, or when did my shell suddenly become very sensitive to whether there's an EXE at the end or not? I used to resolve those automatically. Oh. Okay. Oh, it built and it built. Okay, now we can test. / source builds debug this parser is not working. Unexpected character should still advance, shouldn't it? Which maybe is the problem. So in our manual testing, all right, we at least have a place to look. Assets, Tokenizer. I'm going to pause real quick for a restroom break. I'll be back soon. Just a moment. Oh, wait, what? Where is my OBS? There it is. Okay. I'll be right back. Okay, we're back. We're back. All right. Now, we're running ASCII. And this should work, right? There it all is. It's stuck in DFA state 7. Unexpected character. Huh. Why is that? No. Hello world, exclamation mark and comma. ASCII. ASCII. Let's go UTF-8. Okay. First we'll see the parser. Okay, that worked fine. Arguably, hello world, comma, exclamation mark in ASCII is a proper subset of UTF-8. Let's see what it looks like. There it is. Current character is new line, space, sharp, 0 through 9. It's at the start of the line. Go to 7. Oh, okay. All right, let's go reform some ASCII then. I bet we can make this work. All we need to do is put a space there. That probably fixes it. Backtrace text buffer line. Why? Text buffer line, this is null. Why is it null? There's no way the text buffer should not be null. That's an impossibility. Again, we process. Every set of tokens, we log it. Because of this right here. Okay, we're going to stop testing against ASCII. We're just going to test against UTF-8. Because we are... The ASCII text is not well matched to the regular expressions we've chosen to test against UTF-8, so... So we run it, takes us 7 lines. There's our 3 tokens in context. Here are the actual lines of text. Okay. What I want to test is 3 things. We want to test if it ends in a new line. If it doesn't end in a new line. If it ends in white space. If it ends in a comment. And we'll come around to other tests shortly. So we've already tested, let's see here. We want to test this one first, then this one, then this one, then those ones. Okay. I'm going to run 4 different builds real quick. Works fine. Binary is marked empty. This one should be the same. even though it ends in white space, because this is batch processing. That seems to work fine. Yep, looks fine, just one less line. Ends in a comment. Hey, AK Elements, how are you doing? I was just in your stream earlier watching you put alpha in for your annotations, your notifications. A nice little fade in, fade out is always nice. Did you get it all done? I had to start stream before you finished. Well, that's breaking. Interesting. Segment. Yeah, notifications are done. Added a file dialog for open saving, found a bug in loading shader graphs. There's always a bug. You can't get rid of them all. Did you have time to fix it? I always hate ending a stream in a broken state. It is no fun. This backtrace is not helpful. Character reference, advance, then update. Character reference update. Update. So we're byte offset. Our buffer size, underscore buffer size. I don't think this is gonna. Yeah, that's terrible. Our byte offset is way past the end. I have an idea what's wrong, but not sure how to fix it yet. Yeah, ordering of the nodes is not correctly restored when loading from disk. Oh, nice. Serialization, deserialization. Order matters. Always fun. Okay. Interesting. At least you know where the problem is. I usually find that a good night's sleep, and I'll have more ideas in the morning what to do about it. This byte offset is way too big. This is not valid. Our test buffer is not 170 kilobytes. So it's coming from advanced update. My generator upload munch. DFA root state 12. Process. What this tells me is we've hit the end of the text buffer with our tokenizer, and it keeps grinding even though it's at the end. Currently, I save out the nodes in the order in memory, but I could save them out to the file in the order they should be executed in. But my get execution order should be more robust to handle the case that is saved out of order. Yeah. Are you using relative pointers? Or on read-in, you store them in a dictionary or a sorted list? read them into a list and then sort based on like an index member. There's a few ways you could probably do it, but yeah, picking one. Well, you kind of want your save to be fast. Nobody wants to sit around waiting for a save, but if you had one field that says index and then you sort it on load, it's not really pointer related. Okay, I guess the pins are stored, but the root node of the graph is expected to be the first node in the array. Yep. That makes sense. Well, I don't think dumping it out in memory order is a bad thing. But then, yeah, get execution order to either have to sort them or at least find the first one. I assume that there's a... Still, sounds interesting. All right. We are built in batch mode, but with white space at the end, it is, or with a comment at the end, it is failing. So that's a bug. Let's go. But it accepted the white space just fine. So this is crashing. Oops, not that one. Wait. We just ran. That's it. It ends in a comment. If it ends in white space, this worked fine. I think it actually makes more sense to sort them according to execution order because that's cache friendly. Agreed. So maybe we should do that instead. So if you do that at the start of execution, then memory, writing, and reading would be the same order. I don't want to distract you from your compiler. No, I don't mind chit-chatting. I'm just playing around. This is not like I have a deadline to get this done or anything kind of task. This is my for fun, break up the... Okay, so if there's a comment, it doesn't discard correctly in batch mode. Yeah, this is my for fun day. Not building a product for people, just exploring. Let's see. So that is interesting. Comment, big fail. Every time you save it would be reordered in the correct order, and then I just read it in as during runtime. Don't need to care to order anymore, so that's a good thing too. Yeah. Is it user-initiated save, or is it an automated save based on user input, or like just a save command, or a timer? What triggers your saves? Your node list can get quite large, although I doubt large enough to cause any normal sorting algorithm any kind of major issue. Currently it's user input, but I guess an autosave would be nice too. There's too many features. Actually, I don't like programs that autosave. But I also, so saving is asynchronous, okay. Yeah, your sort probably won't kill your save. The disk access will probably cost more than the actual sort. Back in the day, I used an old circuit board layout software. It was so bad. If you didn't save every 1 to 3 minutes, it would crash. But as long as you kept saving, it wouldn't crash. So I got into the habit of just, even when you're just sitting there, just tapping Control Save, Control Save, Control Save. Something about that operation. So ever since then, I'm an obsessive saver. The old muscle memory was trained. Okay, this is an interesting case, which is failing. If it ends in a comment, fails to terminate execution. So looking at the tokenizer, this is in the batch process. Probably reload. Well, let's see here. Batch, processing by batch. It's not detecting that we're at the end. While not is done, it keeps doing things. Is done checks. It says if we're at the end of the buffer. Oh, and the next state ID? So maybe that's my problem. What if we don't check this? What if we just say we're at the end of the buffer? Okay. Oh, cool. Still sounds like good progress, right? Notifications. Those are your toast notifications you were talking about yesterday. Always nice to know when you've done something wrong right away instead of finding out later. Node ordering. There's the comment. What? Yeah. Okay, so that fixes it. We don't get the comment in our actual token stream, but the line is fully processed and recorded. So that's good. So that's all of those. Let's go back to the working one. Let's go to our make file and change our build flags. We're testing lazy processing. We're going to try that. Yeah, so I have 120 different build permutations, depending on things like encoding and different code paths that all overlap potentially. Okay, so using lazy processing, tokenizer processing, we get, that looks about right. Including nested strings, that's always nice. We get the tokens in context with their line. There's the lines. Okay, so that all works fine. And then make sure this is lazy. Yeah, it was built with lazy. Okay. I'm going to try one that ends in white space. Okay, white space now works for lazy processing. Let's try with a comment. Hopefully it's that simple. The trick will be unterminated tokens, which I don't know if I feel like dealing with today. I would like to get some actual work done. There it is. No comment in the token stream, but there is a token comment in the line, so it did fully process. Should I do it? Should it be pathological? All right, we're going to do it one time just to see what the output is. We're going to start a string, bad stir. So this is a token that doesn't terminate. we should not ever accept until we get that second quote. So ending the text buffer with an incomplete token. Oh, it worked. Did it output an actual error when it was processing? No. So there's our text. Begin, end. There are 11 tokens. Everything looks fine. In context, 7 lines. It does not have... Okay, so it just didn't generate an error. Interesting. It did not accept, but it also did not... What does batch do with that? If that's the case, we might be able to just run the full suite of programs then. Yeah, bad string's not here. There's no error during processing, but the line is there. Oh. Unless this isn't doing what I think it's doing. Start a string, and it doesn't terminate. Yeah, that should be a bad no-no. So at least we know what it's doing. Okay, so let's go to our test. We're still going to break out after the first batch runs. We are going to run the other tests, which we've currently commented out here. This is the trailing white space, a kept token. Let's go ahead and do this. We'll run the test 4 times. Just to be pathological about it. Just because we can. Okay, 3D tools / test permutations. So it should run just the one loop. Okay, and then check the log. Tested new line, ends with discard, discard, and keepable token. So let's just fix the logging a little bit here. Ends with new line, ends with discarded token, white space, ends with discarded token, comment, ends with a kept token. That's it. Try that one more time. Then we'll run the full batch of tests. So, AK, do you have a good war story from your days in the games industry? One time where you came out as a big winner, as the hero? Any old story, just looking for a good story time. You saved the build, you saved memory before release, before it went gold. Snuck in a feature that was too awesome not to. snuck in an Easter egg. Those are always fun. Haha, a lot, although winner, not sure. I mean like that. Yeah, I guess there are a couple like that too. All right, let's hear a war story. I like a good war story where somebody does something clever, or let's see. I'm gonna run this over the full batch of tests. We've got a couple minutes. We are going to time it. We have 120 builds, each one running 4 different strings. So I'll warm it up while you're typing your story. Back in the day, I was fresh out of college, got stuck on an immersive training simulator where they were using a in-house built simulation engine called GOES. I forget what it stands for. Doesn't matter. The render engine was all in C++. The lesson scripting was interpreted from an XML file written, and the XML file interpreter was JavaScript, which then piped commands to the renderer via UDP, running on the local host. Okay, and the render engine would read in assets, and the part that was loading in those assets was written by a fellow that was not a very good programmer, and it would read in from the file 1 byte at a time, like get char, get c, right? Instead of, read file or reading in blocks of memory. So disk access was absolutely atrocious, and as the lessons got bigger and bigger, the developers building the actual lessons were running 5 or 10 minutes before the lesson would actually load up, and there was no no debugger. There was nothing like that built. It was just, we got to get this done as fast as possible. There's no time to do it right, which of course makes everything worse. So these poor developers would type add model to the scene at this location, and then they'd run the sucker, and it would take 5 minutes before they could see if they put the table in the right location. Then they'd close it, then they'd move it, change the values in the XML file, and run it again. And so, everything just was hideously slow. But I did know that the interface between the scripting language and the renderer was UDP. So I started doing a sniff on the UDP traffic, and I figured out what some of the basic commands were. Things like put model, add model by name, and move model to a location. So I wrote a separate application, a little desktop application in Qt, which would say, here's a command that we can issue from the XML, and here are the parameters to it. And then it would output into a separate, there was little input file fields. So if you add file, it would say type in the name of the file, and then it would output what the UDP message would be and what the XML should be to execute that command. And then you could hit send, and it would send the UDP message to the renderer. So when you do add, table model to the thing, it would appear in the scene immediately, and I wouldn't have to restart the whole scene. And then I could say, put the model, move the table to here, send the message. Oh, okay, that's where it is. Move the model here, send the message. Move the model here, send the message. Then once you got it done, you just copy the XML, put it into your lesson, and hit, and then save it, and then you could rerun it. But you weren't doing these 5-minute reloads for every single edit. It was probably the only reason that project finished. Because every single edit was at least a 5-minute wait. It was terrible. Of course, I wasn't allowed to touch the code for the actual render engine, so I couldn't fix it, but oh well. Let's see, the last project I worked on, I did the benchmark for PC benchmark, and I'm not a UI programmer by any means, yeah. But I noticed while profiling that the UI takes 15 milliseconds per frame. Holy smokes, yeah. Big no-no for PC benchmark if you want to run at 144 frames per second. Heck, if you want to run at 60 frames per second, you've just about used your whole budget on UI. My gosh. So I looked at it, and they were rendering the graphs for the UI. Oh, as Bezier curves. Oh my! So you found the issue. Did you fix it, or did you just get kudos for finding it? Bezier curves. Oof. Well, good catch. Yeah, Bezier curves are not cheap. Nice. After we finished that project that I was talking about, they ported Ghost to Unity. They're like, our in-house engine sucks. We're moving it all to Unity. So that was back when Unity was still cool and hip. And that guy that wrote the file, the asset loader that read 1 byte of disk at a time, he quit shortly after that and went to go do something completely unrelated. So I don't think he was even he was a project manager, not even a developer at that point. But as far as our upper management was concerned, he could do no wrong. So I don't think anybody ever quite realized what a mess he made of it. Nice. It's good when you can find the bug and fix it. Oh my gosh. Bezier curves for everything? Yikes. Nice. Good find, good find. Okay, so all of our tests now pass. Every single build combination. Well, that's good. Okay, so if we go to our journal, we've got this one done. This one isn't really done. Do I want to error out there? I probably do. So let's just update this one. Fix the bug with for text buffer endings, destroying the lazy tokenizer. The is done check was looking at the next state to decide, and that is completely unnecessary. It was just a bar. Oh, it's just bar graphs, which is even worse. Yeah, not a line graph where it makes sense maybe to smooth it, but like even most of the time, I would just draw as a first order, I would draw the line graph as points and lines. Even then, but yeah, bar graph I would definitely not use Bezier curves. Wow, that's like somebody learned a trick and then decided to use it everywhere kind of thing, huh? Leaving that check, fix the issue, all 120 build run permutations from test permutations .py now pass. With 4 different text endings tested per build run permutation. Now pass. Okay, so that is good progress. Git status, git add, git commit. Fix bad processing when at end of TxtBuf, depending on what's at the end. Okay, cool. Yes, I would too. Yeah. Keep it simple. Add complexity when needed. Well, that's a pretty good war story. 15 milliseconds. How did that get through? How did that get through? Did nobody complain about 15 millisecond UI time? Jeez. Crazy, crazy. At least it's one of the easy to find things. Man. Okay. Next task. I kind of don't want to work on this bug, but I might as well fix it. So this doesn't break, it just doesn't report an error. So we need to be able to detect that error, or I guess it goes back to the old tokenizer. Oh, it's actually probably in the do accept, which we inject from here. Do project, do accept function cases. This one. Okay, so we say do a bunch of stuff. So there is an error that could be logged at that point. Case rule. So we're injecting this code into do accept actions, which is just we're at the end of a token, and here's the rule ID that we're in. So we should accept based on the tokenizer rule number. If we aren't in a rule, so if it's case rule none, then we're there. Failing silently should not happen. So I guess the question is, what is the rule ID that does nothing? So if we look at the output of this, if we're in rule this, so what rule ID are we ending in? Oh, if we're tracing the, yeah. Okay. Okay, so maybe that is step one. Well, I didn't look at it. It was the feature owner more. Oh, you were the feature owner more or less. Uh-oh. Uh-oh. Well, at least it was fixed. Easy fix. So these rule IDs, where are those defined? Right there, and the 3-digit number is the number itself. Okay, so we can put a little debugging in here. If this is less than 0, log error, cannot accept, no rule ID. else. Let's see, log error. Do I have log warning? Oh. Where was that? That's defined in the project parser. Log error, log warning. Maybe just do a printf then. Sheesh. Accept root rule module 03D current rule ID. Okay, to test this one, we want this one back. Rebuild. Oh, we should static cast to integer. My bad. Oh, okay. If we fix this one so that we can that's how we want to run it ourselves. The last thing to happen is root rule 1. That's white space, which is the thing just before bad stir starts. So basically, we get this. That's accepted. Okay. So at the end of batch processing, there's a small piece. Tokenize the trailing bit. So this, I'm guessing, is why we don't get a printout. So let's do this. So it goes into accept. Did that not? Why is this not updated? Oh, there it is. unless we're being lazy. No, we're back to batch. Huh. It's only at the end. So let's go put this back where it was. DFA dispatch. I'm going to translog the tokenizer. It's going to be too much information, but it will be okay. Maybe. Okay, so we get some new line. We get white space, except by rule 1. Now we get this quote. We munch, we get bad stir. And I think this is the except at the end of the whole loop. Which is still accepting by way of this thing. Oh, interesting, maybe. Maybe we're not resetting that at the after accepting a token. Do accept actions. When we say start new token, what do we actually mean? Right here. We don't reset the current rule ID. Whoa. Yeah, we should do that. That seems important to me. m_current rule ID equals. We don't initialize it either? Whoa, okay. Well, root rule none. Okay. If we're logging, if we're not logging, that's all done. Process lazy batch. Okay. Okay. Was working on the graphics team of the engine, so I was responsible for the PC benchmark and its functionality. Yeah. So, benchmark. How much of that is like home built timers versus using fancy high precision libraries? I know there's are some people who take their measurement very, very seriously. It's all self-built with high-performance timers from the Windows API. Yeah. Like there are weird like libraries people plug in all the time these days. Timers from DX12 for GPU timings. Yeah. Okay. Well, I don't know DirectX, but everything I've heard is that it's much better to debug for than like OpenGL. I don't know about Vulkan. How does Vulkan stack up in terms of debugging compared to OpenGL or DirectX? Okay, so it does not accept Ooh. Yes, I do want to see the result. Let's take a look. It doesn't even look like you rickrolled me. How dare you? I expected something I don't often show screen on stream, but heck. Biggest thing in the benchmark was it's not just CPU, GPU utilization, FPS, but I added super low level metrics like per frame CPU and GPU doing times. Nice. Okay, let's take a. To make this work, I have to trick OBS. So, how long does this shadow pass take? Yeah. Well, honestly, to properly optimize, you just need that much detail. So let's if I share my browser, and then move over. You have to. It's rather a silly thing, OBS sometimes. But okay. Then we got it shared, and I don't remember if I shared the audio on OBS. But any decent project I will show on screen. Where is the settings? It says I'm capturing audio. Okay, here we go. You can see those graphs in 45 seconds. Awesome. Let me know if it's too loud or too quiet, folks. Oop, looped. Nice. Pretty cool, pretty cool. Oh, nice. And frankly, the environments for Avatar Pandora, that's good stuff. Good stuff. Cool. Is that your channel? I've put on your Twitch and followed your link to your YouTube, but there's nothing uploaded there. Or did you just contribute to an existing channel? Games, apps, tutorials, that's pretty cool. Oh, random clip that you found. Okay. Maybe my engine gets there in 10 years. Hey, we're playing the long game, right? We're gonna build gaming empires. Just takes a while. Okay. So what we're going to do accept actions, blah, blah, blah. Ooh, that's the one. So it should see those logging out, which we do in our shell. Then we hit here. This is like the end of batch processing, which happens here if. So it never goes into except. Oops. Tokenize the trailing bit. Okay. Let's go to our tokenizer. We need to add better checks. Yeah, I think for my game, all I've got are frames per second, milliseconds per frame, and number of draw calls averaged over some number of seconds, or like a fraction of a second. So I don't have that high a fidelity in any of my metrics, and it's all using the GLFW time, which I believe is the highest precision monotonic clock on your machine, if I remember right. Okay, now we're getting where I expect. Cannot accept a valid rule, valid rule ID, blah, blah, blah. Start new token, new line, end. So we still get through here. Okay, so that's actually processing correctly. This is now unnecessary. And oh, well, hold on. I think what we need to do is this. The trailing piece. What we care about so an except if we're in that state. Current rule ID. Actually, just put this in as a literal. This is not a very helpful error message. So I think what we need to do is this means you have an unterminated token at the end of your text buffer in an unaccepting state. Oh, that cannot be accepted. I'm going to try that. Pretty cool. I wonder if I have a clip of that old, let's see here. Wait a second. Where was it? Hold on. Trying to find the link to that project I was talking about. Oh my gosh, what a terrible search engine. All right, we'll go to Google, I guess. Here, this is the simulation in oh wait, let's see, that's YouTube. Here we go. Oh my gosh. This is actually probably the Unity-based version of the simulation engine. It's probably not the inbuilt one. But I actually know some of the people still that are in this video. I actually worked with the guy. I recognize that shirt. Oh, there's the guy who did the 1-byte reads. Oh my gosh, it's all in this video. Okay, but yeah. That's the in-house engine we were working with that we ported to Unity. That video is probably the Unity version, not the other one. Okay, let's see. Stray backslash. Oh, that makes sense. I shouldn't have stray backslashes. I agree. Oh my gosh, that was 15, 16 years ago. When did I? 2008. So I was working on 2008, 2009. And that video has 320 views after 14 years. Wow. Yikes. I guess it wasn't a very popular simulation engine. Unterminated. Okay, so here's what we're going to do. We're going to stop the log tokenizer. Yeah, that whole project was a bit of a marching nightmare in some ways, after which the management was very proud of themselves and patted themselves on the back and then failed to land a single other contract on that line. After which the entire division dissolved because they put all their eggs into that one basket. I jumped early. I saw the writing on the wall and got out to a different division, where I then worked in telemetric flight instrumentation for military aircraft standards. Spent, gosh, 6 years doing that. I have some other war stories from that one that are kind of fun. This looks correct. Okay, so let's update our test mutations. So we are going to test, here, this one. We're going to put the bad string back in. Ends with incomplete. That's good for you. I guess it sounds complicated. So what happens? Let's see here. I can give some background on that. So military aircraft are tested in China Lake down by Death Valley because there's nothing alive around there to blow up. And you have to strap thousands of pounds of instrumentation, so sensors like vibration, temperature sensors, accelerometers, etc., to all kinds of parts of the plane, right? Thousands of pounds of this stuff. Then you have to schedule range time to say, I'm going to fly an airplane. And then they fly the airplane. All this data is captured onto hard drives. So they have data acquisition units. If I say the word DAO, that's a data acquisition unit. Is basically the takes the analog voltage signals off the sensors and dumps them into a hard drive where they're stored. So scheduling one of these tests is insanely expensive. They almost always buy new hardware for each different flight because you want to know if your airplane wing is going to start vibrating itself off if you bank hard to the left or something. So that's flight instrumentation. Then you have different large vendors that supply the ranges with their equipment, but it doesn't mix well. So you have company A and company B, and you kind of have to decide, do I buy all of my stuff from company A or all of my stuff from company B? Because I can't slap both onto the same flight very efficiently. So the government said, screw that. We want a set of standards for how you all talk to each other. And then we can buy this piece from here and this piece from there. And then we can, outfit our planes more efficiently and with the set of tools we need. So they were developing these standards. And here's where the war story starts. To configure the system, you're supposed to send around this XML file that contains, what sensor goes where, who's in charge of storing that data, what data should we make available over the radio? Like you have limited bandwidth from the airplane to the ground, so if you have high priority data that you want to see while the plane is in flight, it's much more efficient to say, oh, go make another left bank than to re-instrument your plane, reschedule range time, and take off again, right? So certain data they want streamed to the ground. All of this stuff was configured in XML files. And the standard was largely encapsulated in an XML schema. Well, in the beginning, all the different companies and different people who were, the range commanders that we were all talking with, they all wanted different things. Oh, hey, we want this. Hey, we want that. So the schema was changing every week. There was a new release. And they wanted me to build basically the authoring tool for configuring the system with a user interface, and then it would output this XML file. But every week it was changing. So I'd start writing up a UI, and then next week, oh, hey, there's a new schema. So at some point, I quit working on that. And I took 2 months where I just lied to my boss, actually. How are things going? Oh, they're great. I'm working on this. But what I was doing was writing a piece of software that would parse in the XML schema and then emit all the back-end code. So we also had a database separate from the XML file. But it would generate the database, all the Python code interface with the database, all the Python code to generate and parse the XML, validation, etc., and then hand that to my UI. And so at the end of those 2 months, where I did not actually keep up with anybody's new schemas, I could then pull in a new schema and generate 90,000 lines of code, and then just make a few updates to my UI as needed. Then I was able to keep pace. So that was that war story. I just lied to my boss, like, nope, here's what I'm working on, here's where I'm at. And at the end of the 2 months, I came out so much further ahead for having done that. Because then I was able to keep up for the next 5.5 years with every schema change as fast as they came out. So that was fun. All right, so this bad string one, I want to say you have to do an extra check. What I want to know is, did it output? Did I get an error message? Where does it do that? Oh, context. Context. That error should be in the context. Wait a minute. Why am I logging that? It should go in the context. Context code context. That's the whole purpose of the context. Is to add message. Message types, warning, or error. So tokenizer. Instead of log error, the tokenizer has a context. Context message type. Unterminated token at the end of your text buffer cannot be accepted. All right, that's much shorter. Right, honestly, let's see here. We have set context. Which we even used to get the buffer. When we process, we clear the tokens. We should probably clear the messages as well. If we want to keep reusing context. I think there's a clear messages. Oh, just clear. Easy enough. Oh. Nope, not that one. Okay. I don't have a clear messages. Oh well, it's fine for now. Okay, so what we're going to do is kind of a run. Automated test. This one. Okay, so expected errors is a thing we're going to pass in. Expected error count. After all this is done, the context dot, let's see here, message count is equal to our expected error count. Expected modulus d errors. Got some other number of errors. Expected error count. Context, message type, error. We might as well do an expected warning count, right?
They're gonna need cola.
Okay. Wow, son. That was very loud. We'll default these to 0. Most of our test cases are not going to worry about those. We'll only really pass it in with this one. Expect 1 error. Okay. I'm going to run one of these tests. Oh, man. Okay. I'm going to go use a restroom real quick. Then we'll run the test. Just a moment. Okay. We are back. Assuming the compilation completed successfully, which it did not. Okay. I know what this probably is this. So verbose. Well, let's just get a count. Error count equals count. We actually aren't really using the context for error stuff very well. That is probably a thing we should fix. Okay. Here it builds. Hey, JTL, doing good today, doing good. We've fixed some issues, doing some testing. It's not bad. I can't type though, so that's a problem. Expected warning count. So I think we're getting close. Source / test our permutations of builds and come back up. Oh, wrong directory. Tools. Okay, so it's going to rebuild VV. Then it'll build one build combination and test it against the 3 different encodings, which it builds each one of those encoding setups. Okay. And then if we test our log file, oh, it's 5 tests per, because now we have the incomplete token test, which did match. Cool. So test permutations dot py. We're going to run all the tests. So it's like 120 different build operations. Each build runs 5 pieces of text. Oh, got it. Something didn't compile right. We have a build combo that, okay. Root rule none. We did not properly namespace that one. Okay. And how are you doing today, JTL? I did get a call from those people you told me to expect, so that's not too shabby. Root rule none. That exists in 3 locations here. Oh, maybe in here. Not that one. Root rule none. Nope. Okay, good. I told him he needed to call in the morning. Yep, he got me in time. Brought up a couple things we probably should discuss, so. Always fun. Let's see. Hey, it worked that time. Out of curiosity, then. You know, the build commands that it tests. I really want. While that's running. Manual test logs all of our defines. I want this test also to log out what it was built with. Okay, so we're 14, 15. Gotta get through 40 of these. Each test built and run 3 times. Another thing I want, while I'm thinking about it, log messages. I would at least like them in my output log file. Then we can verify that. Let's see here. So in our shell, it's still cranking away. Oh dear. Oh, well, that's actually interesting. If we load up the log file, might actually see here. Oh, that's a fail. 4 ends with incomplete. Expected 1 error, got 0. Okay, so we have some problems. There we go. Unterminated token at the end of your text buffer. Fail. One of these failed, the whole thing should fail. Oh, wait. I see. Never mind. Where did the fails happen? So there are failures here. That's okay. We return that. Okay. Where does the pass get written? Um, these ones are in the log. Okay. All right. One thing we need is in test permutation.py. Execute test. Should execute that it contains pass? Oh no. We want that it doesn't contain fail. Utilities check does not contain. For sure that's what it's called. Does not contain. All right, now we find out which ones are broken a little bit more efficiently. Oh. Batch is working. Macros functions, lazy. Fail. Oh, we're back to lazy failing, huh? Shoot. Now that shall be in the old log file. Result false. Okay, so when we're lazy, we get a fourth line. That may be the test setup itself. And it's literally just a lazy. Okay, so let's go check our test setup. When we do lazy, the line counts are wrong. But it ends wrong for all of them. So one line, 2 lines. Okay, I could see ASCII failing. I wish I knew which test flag it was run with. Which test flag? Test ASCII. If it's only the ASCII ones failing, that would be nice. That would be something I could understand. but it's not. ASCII fail. Expected 3 lines got 4. Yep. So in our test.py. Oh wait. Oh, interesting. We need slightly different strings if it's ASCII. In fact, if it's UTF-8. So or 1. If def um, okay, we want to get through this quickly, so let's swap our batch and lazy. So lazy happens first. And then we want to short out after the first round of tests. So we want an early failure and a smaller log file I can dig through quickly. Yes. Oh boy. ASCII, Latin. See, the fact that UTF-8 fails, I don't understand. Breach encoding. We build out a new token thing. And we build the executable. Basically build our one object file and then the executable. Execute. Make sure it does not contain fail. Oh, goodness. So in ASCII, no, I would still expect a \n/r to be fine. Let's go take a look at that source. Pattern, even a bacon converter, \n \r. \r. Okay, so that, they should be fine in all the builds. Never mind. So we just have an issue of, okay. Trailing bit. If it's valid, accept. New line. If the last character wasn't a new line, \n \r should accept. Oh. Ooh, okay, interesting. If the last character, so let's go to our log file. Result fault. ASCII, Latin 1, this thing. Pass. Ends with a token that we keep. It accidentally counts one extra new line. Kept token, let's look at that. So line 1, line 2, line 3, that's 3 lines, but it's reporting 4. This will be line count 0 until we hit this. Then it goes to 1. This will be line count 2 until we hit this when it becomes 3. Well, 2 lines. Then we read this, and at the end we have to accept one more line. If I keep this token, why is it getting another new line? Unless... ends with kept token. There a pattern? Let's see here. It's only with lazy, right? Oh, no. Hmm. If we, I guess it doesn't matter. The UTF-8 version will also likewise fail. Tokens, we don't log the token context for now. Let's try and just run it. Let's see, Triusio, yo, compiler in Python? No, tests in Python, core and C++, correct. Lexical analysis. We are using C++ to build a tokenizer generator at this point. And we're testing it against all of our different options. Do you know the V developers from VLang? I do not. Welcome to the chat, by the way. VLang. V programming language. Simple, fast, safe, compiled. For developing maintainable software. Nope, never seen it. Oh, something got my eye. Something's irritating. Oh, okay. Bounds checking, no undefined values, no variable shadowing, immutable variables by default, immutable structs by default. Okay. No null. No undefined behavior. Oh wow. That is a big promise. Somewhere to go. Okay. Cool. No, I don't know those developers. No, what we're doing is probably the wrong thing at every level. A tokenizer generator is not usually necessary. Tokenizers are simple enough. We're building it this way because I want to. I want to do the NFA, DFA thing. I want to build it with every combination of ideas I want, and then we can build and compile and compare the performance. So right now our tests, there are 120 different build combinations. So if I run this, it's reading in a new line. Fascinating. So here's our text. Hello world, ASCII, comma 13. So our tokens are hello, then the string world, then the keyword ASCII, comma, and 13. Those are all correct. Line 1, line 2, line 3. It's throwing me a new blank line where there shouldn't be one in lazy processing. So interesting. That take too long to respond? Sorry, I was deep in the codes. I do that from time to time. Nope, I had never heard of VLang, but it is now a tab open that I can look at. How does VLang usage levels look compared to other ones? 2019, inspired by Go, Oberon, Swift, and Rust. Free open source, MIT license. Okay. Designed by Alexander Medvednikov. Weasel, official mascot. Cool. Okay, okay. Nope, I don't know them. It looks like I just took too long to respond, so that's too bad. All right. So where's it getting this fourth line? We're going to put this thing back in. And then we're going to test again. Ooh, 3:30. It is almost time for snacks. Boom. All right. So we get 1, we munch it, we go to 3, we munch it, we get nothing at the end. We accept the token. We keep the token. New line. Why? Why? Oh. So at this point, we accept the token and we realize we're at the end of the buffer, so we call new line. But then it computes the next token, and this one also calls new line. That's okay. So if we go to Tokenizer and we go to the trailing bit, this is the end of the batch. This is the end of the lazy. If we are done. Maybe this one gets that. So we only force accepting the trail if we have something worth new lining on. Something like that. Boom. Now we've only got the 3 lines. Okay, I think that is correct. Let's go over our test again. Lazy should be up first for testing our permutations of build options. Pass, pass, pass. Nice. Okay. We want to get through all the tests one time. So that was 13 seconds for one test, although some of that was building the VV. So I'll be curious to see how long this takes. So 13.1 equals some amount of time plus 1 unit of something. And we will have some other time equals x plus 20 units of something, which means we have 2 equations. We should be able to set up a set of equations. X equals 13.1 minus y, which we can then plug into some number equals 13.1 minus y plus 20y, which is really 13.1 minus or plus 19y equals our total runtime, which is something like 4-ish minutes, last time I checked. Therefore, some amount of time minus 13.1 divided by 19 equals the average execution time of a single test. Fail. We're still failing? Only sometimes. Interesting. Is it only when lazy and macros? Is there a macro I need to update somewhere? We may have to look at that. Lazy macros. I think it's lazy and macros. So one of our macros on the lazy branch is wrong. Lazy macros. Okay, so let's go take a look at that log file while we're waiting. Result false. Expected 1 error, got 0. Do accept. Right now, that's my guess. Expected an error, but it didn't get one with an incomplete token. Okay. Lazy macros accept. Interesting. Okay. Yeah, I really want all these tests passing before we start going down the go-to branch of coding, because that's going to be a fairly significant chunk of code. These different paths all overlap and reuse each other quite a lot. The state-based one is not. It's going to basically duplicate all this code 4 minutes. So that's 4 times 60 is 240. So 244 seconds, call it. So 244 minus 13.1 all over 19. We're running about 12 seconds per test. Cool. Okay. Accept. We always call to accept actions. Do accept actions. Do accept actions. Interesting. Oh boy. We go with this. We expect an error on the incomplete one. So go to here, we go to test.cpp, and we take this one. It's the one with the unterminated string in it. We can test against that. All right. Maybe. We'll see how that turns out. Processing. Compute next token. End. It did not put out the error. Interesting. Next token, compute next token. This all looks correct. These lines look correct. Tokenizer trailing bit. Start character is valid. We try to accept and then get the new line. This accept, when it's a macro, a lazy macro, lazy, do accept. So who set underscore current rule ID, start new token. So anywhere where we start a new token, okay, seems reasonable. Start new token. This one. We didn't have it on the lazy branch. Okay, once we figure that out, easy peasy. Let's test and run real quick. That should fix it. Ah. Um, oh, oops. There we go. You always need to have that new line escaped. How many start new token definitions are there here? Current rule ID, current rule ID. Current rule ID. Okay. if the token has a start character, and that means we need to grab up the trailing bits. Means, unfortunately, a lot of this tracing stuff is not in the macros, and I really don't want to put it in the macros. Oof. But this is the first quote. We go to H. That's a quote BADSTR end of string. And then it just doesn't go in there. So the token start character should be valid. Except calls do accept things. Oh wait, no. There should be no pound define, pound define do. Yeah, no. Only the one. Void do accept actions. These are heavy lift enough. Huh. Accept modulus D. Static cast to an integer. The current rule ID. Lazy macros didn't have that thing in them, but they should now. Unless it didn't rebuild. Maybe it didn't finish the rebuild last time we ran it. Accept -1. Interesting. Tokenizer rule ID. None. -1. do accept actions? None. So I just printed out 1. -1. Right here. Accept -1. Oh, that should be added to the context. Okay, so maybe it's fine, actually. Okay, so manual testing is not outputting everything I would expect. Okay, we can fix that easy enough. Reference text, set context, lazy batch processing, tokens. Okay. Context.num messages or message count given a VV parser context error. Warnings. Okay. Then in that case, we will do the following. Context.log messages of type error and of type warning. Okay, now we should see it logged out to the console. We're manually testing. We need to know these things. Message type. All right. Honestly, I thought this might be more painful than it has been, even with the. We think we're done. We're not sure we're done. Kinds of things. There we go. Unterminated cannot be blah blah blah. Except blah blah. Okay. Tokenizer. That goes away. I think all the tests should just run now. We'll stop if any of them fail, but that should fix it. We did have it fixed, we just weren't logging it in the manual test case. Okay, so this is the lazy helper, lazy macros, it's working. Yay. All right, now we just need 40 tests to run. Not bad. Well, that's running. Jalapeno popper run. Be back soon. Yes, jalapeno popper time. We'll check the results when I get back. Okay. Hey, 128 tests succeeded out of 120 tests. So we are perfect. We're good to go. Well, I've got a copy of file here for my children. So I'm going to start that. Which is this cable? That's the cable. Second one here. Ugh. Oh, is that the right file? It looked like the right one. Hold on. Untangling USBs. Oh. Oh, it was the right one. Okay. I'm gonna go copy this file real quick. Okay. All right. Just give me a minute here. There's this one. Nope, not that one. This one. Copy from over here. What was it? All right. So that's right. Okay, so our tests have all passed. We're good to go. All right, all tests now pass. Also testing for error message from unterminated token at the end of the text buffer. Nice. So all tests pass. Oh, excellent. I was afraid that would take me all day, so that's not bad. Let's we're gonna this has to do with go to. It's untested. Is the file copy finished? It has. So let me eject this and hand it off. Uh-oh. Which file is it? G. This one. What? It says it's in use. It is not in use. I beg to differ, computer. There it goes. What? Why did it re-plug in? I just ejected it. Eject.
Just give me a ring.
What?
60? You want an hour and 20? 120. No, not.
Okay, my computer's doing something very bizarre. I can feel the magnetic platter spinning, so. Oh. Alright, well, hopefully that worked. Here you go. It's in the not owned folder.
Okay, thank you. Love you.
Yep, bye. Okay. Kids taken care of. Debugging taken care of. VV TokenizerRule stores the actions as strings. Pardon me. Make some flags. This is like just a small quality of life thing, not really that important. But it shouldn't be that hard. Let's put it in. Let's do it quick. This should be done in less than an hour, right? Okay, VV Tokenizer rule pass in the actions as a string. That's fine. But we shouldn't store the actions as a string. We should instead say something like bool m underscore keep. Oh, action keep, action keep, action new line. I think those are the only two actions right now, which is why we have these things. Why we don't need that anymore. BD TokenizerRule. M underscore actions shall become action keep action new line. Keep will be the default. Action new line is false. Now when we set the actions, oh, let's see, copy constructor. Yeah, we don't actually want a lot of copies made, so, well, I'd rather reuse code paths than have a whole separate thing. But that means we do need a different set. Set. Instead of actions, we take a bool action keep, bool action new line. This one actually mostly will do this, except for that. Then we say m underscore action keep equals action keep, action new line equals action new line. This one is basically going to call the other set. Give me rule ID. Actually, put those all next to each other. These string copies are slightly different. Rule ID, token ID, name, regex, do keep. Do keep equals true. Do new line. Action new line. We're going through if C equals K, action keep equals true. If C is, oh wait, keep discard KX and L. Action new line. I'll just make it a switch statement to make it easy. Case K X and L. And this is small enough we can put all in a single line. So one time through the action string, we get every combination we need. Action keep, action new line. We were not consistent at all, were we, in our capitalizations? Okay. So this set calls that set, therefore there's fewer code paths. This constructor now just takes other dot action keep other dot m underscore action new line. Same thing with the assignment operator. And actually, is that it? Is that all we have to do? Check it out. Of course, we have some things we haven't done yet. So, oh, we don't need that. Actions width is 1 or 2. So did I just remove this thing? Yeah. Nope, doesn't matter. Actions. Rule. Log. This thing right here. This right now is our issue. Actions width. In the logging, we don't return that anymore. The rule. Okay. Actions is the only piece of this that we need to revisit. Star. actions, not char actions 3. If do new line action sub 1 equals L. Otherwise, action sub 1 is the end of the string. With underscore do heap. Oh, action heap. Oh, we can do this more efficiently. Action sub 0 equals action keep question mark. Then it's at K. Otherwise, it's a discard. Action sub 1 equals. We do a new line action. If so, it's L. Otherwise, it's \0. And actions 2 is always 0. Easy peasy. Do a new line. Action new line. Action keep. Where did this one come from? That. There we go. Yum yum. Action new line false. Action new line false is the default. Therefore, set. That's the default. There we go. Oops. I'm glad we tested it once before we ran the full suite of tests. There we go. Perfect. Do we run all the test permutations before we commit? Probably, because I think we're done with that. Because we are going to have more actions that we're going to be able to do later. For now, it's literally keep, discard, which are mutually exclusive, and mark a new line when we get this token. So. Okay. Go to. This is going to be a complicated one. We'll probably do go to batch first. Batch lazy, I'm not sure how I want to do it. I'm getting kind of excited to start testing performance, although we're nowhere near where I want to be. I don't want to test performance until towards the end when we've got all the pieces in place. Because otherwise we're going to add a feature and it's going to change the behavior of things and cause bottlenecks where they don't belong or where they weren't before. So measuring prematurely isn't going to tell us anything about the different uses we have here. It looks like that change didn't break anything on any code path. So and this is 2-3 levels of metacoding and 140 permutations of code paths that we're testing. So 120. Pretty good.
You go first.
Now I'm curious. Tokenizer. Actually, let's go to VB test parser. Log error. So that's inside the file buffer. This is the context. So this one should be added to the context, actually. In the generated tokenizer, do not log messages, only add them to context. It's like this one should be an error in the context. This one should be an error in the context. This should be an error in the context. Yeah. Mostly in the unexpected character count, so that's interesting. Okay, 120 successes and all is good. Journal. We've done that. Updated VB tokenizer rule to store actions as Boolean flags. This will make adding more actions in the future a bit cleaner, easier. Go change up our make file. Let's go back to batch processing. Let's go back to functions. the tokenizer rule stores actions as flags. Okay. Not bad, not bad. Doo-doo. We should fix this. In fact, like nothing should log in here, except these two functions by way of the context. So TxtBuf implementation. Okay, so we load the text buffer before we load the context. So this I'm unsure how I feel about because the text buffer doesn't have a context. Wait. The text buffer references text. So the text buffer context reference text context read file. The context has a buffer. The context, do I forward declare the context and then pass it as a pointer? Maybe. File reference text. So the text buffer copy text reference text read file. I don't think there's any copy text errors that come through. Only if open. This doesn't log anything, it just passes through. Okay, interesting. So let's look at our okay, character reference, string reference, text buffer, then context, because the context references this thing, which references these things, which reference this, and this also references this. Okay. So I do have to forward declare that. So VV project parser. Context. Then TxtBuf. When we read file, we can pass in a context pointer saying here is where you will put your errors. TxtBuf info, read file. There we go. And instead of log error, we say context add message context message type error. There's no warnings, so let's go find error comma. Message. Just prevent long lines from building up here. Now when we read a file, we just pass in this, saying stuff, the error messages here. That may fix parts of it. As long as it builds. It doesn't. For declaration of class. Yeah, what? For declared it, which means I can only use a pointer, right? Larg. All right, let's go change context. Well, hold on. Incomplete type context. I forward declare it. I have a pointer. You should be able to combine that, right? Buff. Hmm. All right, let's put these 4 files back the way they were. In this one. Okay. Git restore file. TxtBuf impl project parser, and this one. Code snippets. All right. Another place this could happen. VB project. It's in the tokenizer. So log error becomes m_context dot add point 2 add message of context message type error. think that's it. The only place this happens. Let's try this. Maybe we can get rid of some of them. Oh. Ah, we run it. I haven't. Oh, no, I didn't want to do that. Oh well. Okay. Blah blah blah. Let me think about this. This for declaration thing makes me a little sad, but I think I can pass around a lambda instead. So let me think about that for a second. I'm going to pause for a restroom break. All right. So, I think we may not have been that far off. Go back to context. Instead of this, we're going to pass in a lambda, and let's go in here. Read file. This. I'm going to take a const char star. Add message. Message type. Error. Message semicolon done. We're going to pass a lambda in. We should not define that inside context. I need an example file. We did it here. We type deft std function. So we're going to have a dependency on functional. void report. Oh wait, no. Post star report error. Let's see here. Report error func. I guess that can't be private. In fact, TxtBuf import probably needs to be the one to do this. TxtBuf.cpp read file. TxtBuf implementation report error func. Report error func. Add message. Oh, good. We do handle the formatting there, so we can just use it. Oh. I think a lambda with a dot dot dot. I don't remember. C++ lambda with dot with bars. And I'm already out of jalapeno poppers. I think C plus lambda with dot dot dot. No. Mm-hmm. I want a template. Variadic arguments. They go in a lambda. And the lambda captures use the last parameter of VA. Start the program as a more not diagnostic. Now let's just try it. Right? What's the worst that could happen? Report error func. What are the odds? Let's me use variadic arguments in a lambda. Oh, which is not quite right. I'm not surprised there are errors for multiple reasons. Report error func has incomplete type. Yeah. Because we did not import functional, I don't think. VV test parser. Oh, we do have functional. Okay. So I really don't want anything to log. I just want to queue up all messages in context. TxtBuf input. Report error function. Const char star. Oh, okay. std function with variadic parameters. Does that give me what I want? std function ra dot dot no yeah. Ugh, I don't want to do templating. I want templates. I want variadic parameter list. I don't want template. std function with vargs. Okay. Stop it. As a parameter. Oh, maybe this one will do it. Let's see. I'm going to call void int. That's stupid. Who's doing this? Variants. I don't want to use variants. Long solution network for you. That's dumb. Wow, there's some really bad advice on overflow. Proxy class. Yuck. Oof. std function with vargs. Must be at least one parameter before the ellipses. Yep, check. std function. Why are they doing it with variadic crap? Oh. All right. TxtBuf impl report error func. I'm out of gum. I need to get more gum. In file included from VV test parser. Any other use? And the const charge. Okay, that's gonna make me mildly upset. So dot 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 in the case of declaring. Now let's see. It has to take a VA list, doesn't it? Okay. C standard arg does come in. Okay. And I think we can still do this. VA list args. Add message. VA list args. Basically do this. Now, in this case, all I need is args from format, VA copy. Oh, wow, come back. Start args. And here we copy into 2 from 1. And we count, we end. Oh no, we don't end. Args2, args2. Then we use args. We don't have to end args1. Okay. args2. We copy from args to args2. This one did it. It started. It does not do this work at all. Instead, add message, message type, format, args. Then it ends the args. Okay. We copy, we count how long it'll be using that copy, and then we end it. And we do the actual print. And we're done. Okay. That does that. And when we read a file, this is the important thing. TxtBuf info VA list args. TxtBuf impl may need a helper function for us to get this to work right. But let's try that first. Hey, Suki, how's it going? I think that my compiler made a really good Lexer accidentally. Ooh, I made a working install sh. Cool, cool. Let's see here. I have too many GitHubs open. That was not it. Nope, wasn't that one. Okay, this was it. No. Where did that tab go? My own programming language. Yes, this is the one. Okay. Right, this is the right one. Cool, that's awesome progress. Let's see. Let's see, I have, yes, calcium, that was it. I've got the tab up. Cool, cool. Will not parser it in. Had a quick scan through, doesn't look tons different, just more and more stuff. Cool. Yeah, you got a lot of stuff in here. It's nice, nice. Declaration rparen. Yep, yep, yep. Cool. Let's see if we can all the way back up here. There's the two-sum program. Yeah, awesome. Right now, I work on the next build, less buggy. I think it'll be the first stable release. Oh, cool! So you're getting ready for your carbon dioxide release. Okay. TxtBuf implementation. I think we can just about do it, but we need a private helper here. Void report error const char star message dot 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 VA list args. Basically steal this. After message VA end args. And the other thing we need is the report error function. report error func. Giving me message and the args. So now replace this with report error, which should, oh, well, it's not quite right, but report error func. Report error. I'm going to try to make that build. Okay, let's see here. I think it'll be the first stable release because there is something I made, which is I made a VS Code extension for the language. Oh, okay. It isn't in the extension list, so one needs to install that extension manually. Yeah. Yeah, getting something like that approved for general usage may be a little tricky, but still pretty good. Semicolon. Semicolons are hard. Okay, super close. Maybe in context. Because we copied it from there. That was no problem. It is easy though to download manually an extension. I can even make a script that does it automatically since it's always the same path. Nice. Nice. Ignored attributes of template argument. I don't know what that means. Does it run? It does run. Do we run the full test? Okay, so I'm going to look for log error. This should be the declaration when we log it out. And that's it. Okay, good, we did it. Generated tokenizer no longer logs anything directly, always reports errors to the context. File reading not tested. File reading failures not tested yet. We should run a full batch of tests just to make sure. At least now there is syntax highlighting and some libraries. Nice. Next calcium release will probably compile directly into assembly. Cool. There is a higher chance of still transpiling into C. Yeah. It's not a bad way to get your language off the ground. Well, shoot. I thought we were just going to win here. It's going to crash and die. Ignored attributes. I mean, do we do this? I don't really like it. W no. Ignored attributes. I don't want to. No. Ignored attributes. It does work, so I guess that's why we do this. Whoops. Where are we? Oh my gosh. Active projects. We're not in the directory I thought I was in. Oh. Need to add this to script. Specifications Python -w no. Okay. That just builds and runs. Let's see here. First, I transpile to C, then I'll make a fork to compile into assembly. But if I want to compile into assembly directly, I'll have to make a sub-language to ease the cross-platform. Basically, cross-platform assembly would be nice. There are, well, yeah, that gets complicated. There are things like FASM and NASM. If you know your, all my tests are failing. With all of these. ends with incomplete. Expected 0 warnings, got 1. It shouldn't have a warning. I hope it's simple enough. Expected a warning count. Nope. I didn't log any of them out. Real easy to parse it and then compiling new assembly. Yeah, intermediate languages often seem to be a thing. Like, you kind of have to go through that stage if you want anything remotely cross-platform. After the assembly compiler, it'll be time to add a JIT compilation. Oh, interesting. Have to get 1 empty warning failure. Warning, and it's an empty warning. Message count. If it's already a compiled language, why would you need a JIT? Unless you want to embed it inside of another process, your compiler, and treat it like a runtime language. Don't expect 1 warning. I expect 0 warnings. How did I get 1? I'm confused by this. The ease performance make it better for debugging, but that would be more at the end that I would implement a runtime compilation. Yeah, okay, that makes more sense. Warnings 1. Fascinating. It's an empty warning, though. There's nothing in it. confused. What I would focus after it is done is to compile only parts that are changed in the code. Yeah, yeah. Incremental compilation. Not sure why we're getting this extra warning message in here. It's empty as well, so that's slightly confusing. Messages, 2, 1 error, 1 warning. Errors, there are 1, warnings, there are 1. So that is definitely wrong. Context. Add message. Yeah. Okay, let's just do some things here. Context dot add message. Static cast integer message type. It's whatever. Is the messages. No messages. Not sure where that message that's a warning is showing up. At the moment, it isn't necessary because I must get the compiler to be working really great before. Ooh, fix major issues. Let's hear about them. While I debug my stuff, I can hear about your debugging. Oh, are we really? We need to trace the tokenizer here. Now there's another major issue, I think. Floats. Uh-oh. Yep. Floating point will get you. 2 messages. Let's see here. Add message type is 1, and there are 1 messages. So how is there 2 messages at this point? I don't understand. We only add 1 message. Never mind, it was already implemented. It was just implemented in a super lazy way. Basically, I accidentally implemented floats. Oh, yep. Sometimes that happens, especially if you're transpiling into some other language. Sometimes you get a freebie just because it's not as far off of usage of the underlying language. Message count. this right here. There it is. It was counting double. You did not copy paste all the stuff. Now it will all magically work. Thank goodness. I have a dumb idea. What if I literally make it? Make what? And usually making things yourself is not a big waste at all. That you can use def instead of fun. You can use both of them. Yeah, you can use both of them. That's, I mean, it's up to you how many keywords you want to add to the language. But yeah, there's nothing stopping you. I once prototyped a language that does assignment left to right and right to left. That language is no longer with us. But it works. Because in my mind, when I'm thinking assignment, I think sometimes it's like I want the destination equals a source. Sometimes I want it flipped, like the way that you read it out loud is this value is assigned to that variable or something. So reading left to right, right to left. I think my language is basically C and Python made a baby. Well, we got to keep it PG around here, so. But yeah. It compiles, transpiles right now to C. It is PG what I said. Exactly. Yeah, just no more detail about how babies are made. So C and Python. Well, Python is built on top of C already. Like anything that's performance in Python was built in C. I think the Python virtual machine is all in C. There are decent interfaces for implementing things in Python and C and having that be available on both sides of the wall. So I'm not too surprised. I wish I could remember where I found it. Let's see here. Let me go do some digging around on this runs. It wouldn't make sense because it is an expression. Yeah, I know. I'm just teasing. Original bash shell source code. Come on, what? Oh, okay, my computer is driving me crazy. Maybe. No, all right, whatever. But basically, the guy who did a lot of the bash shell back in the day, it was all written in C, but he didn't like C, so he did things like, let's see here, scratch buffer. Pound define if something like that, and then pound define then was this, and then pound define phi was the closing bracket. So then instead of writing if statements like this, you would instead write something like looks like bash if condition then ... phi. So it's still C. It still compiles. It's still perfectly valid C, but like he's using the precompiler to redefine his syntax to be more bash-like. So I thought that was amusing. Well, it wouldn't make sense because yeah. Except it was a ton of stuff that he did this too. Like his code did not look like C. You have to had to know which pound defines were all there. So we could add a text, we could add a read invalid file failure. We could add an unsupported character test. So let's put these in the to do, but we're not doing them today. Testing test for file reading and failed file reads. Actually, let's make that 2 items. Test for unexpected character. So we have more testing we can do. Oops. Okay. That all looks pretty good. Okay. Generated tokenizer. Now no longer takes. Wait, what did we fix? What did I leave off here? Oh, we went circled back around and did all that. So yeah, that last journal entry is correct. No part of tokenization were logs, but only stuffs errors into the context. That's much better. Whew. Okay. I have another dumb feature, but it is in an if statement. It replaces if x and not y, if x but y. I mean, that's not hard to implement. Yeah, it's easy enough. I once wrote a prototype for a language that had multiple. Okay, here's one for you. This drives me crazy. Here's one you can implement. You ready? If x is greater than 0 and x is less than 10. Okay? What this is between, right? So I usually write it in this way. I force myself to be very disciplined and say x less than x and x less than 10, so that it's always low value high. Okay? So I force myself to use it that way, but I would prefer to write is 0 less than x less than 10. I want a between operator. I want to be able to do this. I want to be able to do that and that and that. That's what I want. I want all those different combinations. This is what I want. Between not clear, low then value then high. But this I want between, be very consistent. This would be the better one, in my opinion. I want this. I want this. I want this. And I want this. Because if x is an expression, then testing it here means that I have to create a temporary variable up above so I don't compute it twice, or so that I don't rely on the compiler to compute it twice. If it's an expression inside of a ternary operator, then it just evaluates once, then is compared even in situ without having to create that variable, that temporary variable manually. And it's just clear. You always go low, mid, low value check, high. That's what I want. I want languages to have that. I could implement variables like for 100, if else for. Yeah. So you're saying maybe like something like if x in 0 to 10 or 0 to 10. I've seen a couple different syntaxes for it. That wouldn't be the worst. Okay. It would be element. I don't know. Mathematically, I like this syntax the best, but it's your language, you do it. But I would like to be able to check ranges trivially and know that it's compiled to something sane where x is only computed once. It's checked against the low and the high value without me having to do this. I don't want to have to put the and in. I'm lazy. And like I said, in this case, it's not even clear that it's a between unless you look at it for a few seconds. And we can make it even worse. We could say 10 is greater than x. Like, that doesn't look like a between at all. But we can do it. So there's an idea. Some way to check between this. If x element interval. Yep. Yeah, I want that. That's what I want in my languages. Okay, so we did that. Honestly, what do we got? Oh, 15 minutes left or so, half hour. Let me go try to make some of these tests we just talked about. We don't really have much time to start the go-to stuff, but next week is go-to week. We're starting building the go-to DFA dispatcher. Oh. And it's going to be a beast. But fragments of everything already exist, so it shouldn't be a lot of copy, paste, move things around, kind of change the way things do it. But let's do a test for unexpected character. Oh, or invalid character. Oh, I don't know if we can do that. Let's see here. What happens? It always happens on Munch? Well, here's an interesting question then. If we feed ASCII an invalid value, it's impossible to feed Latin 1 an invalid value. Well, hold on. Let's not overthink this. Intervals could be only used in if statements. These intervals are just more flexible than for less than x less than 1, greater than 1. I mean, not any if statement. Like, wouldn't you want to be able to do something like this, where you say bool state equals 0 less than equal to x less than 10? So this ternary operator resolves to a Boolean, which you can store in a variable. You don't have to be inside an if statement to do that. Here an example code. If x element of 4 to 100, then do things. Yeah, that is, yeah, exactly. That's reasonable. If element, blah, blah, blah. I mean, if, yeah. So in your syntax, equals x an element in 0, and you have comma, right? Comma 10. So this is a binary operator, EL, element, which expects a range and a value to compare against. So X is an element in this range. I could live with that as well, as long as I have the option for something like this. So syntax-wise, X is inclusive and a round paren is exclusive. So if I had round paren 0 round paren, it would mean not 0, not 10. So this would translate to 0 less than x less than 10. And if I put a square bracket in, it means it's inclusive, so it would be less than equal to. Oops. And then of course this. As long as I can check ranges like this, where I am very clear about what's included and excluded from the end ranges, that sounds great. Here's literally the math intervals. Let's see here. This can be done using a function call without any specific features. Yeah, it is, but Suki's playing with a fun little personal language, so. Yep. Yeah, so this is definitely Suki's personal language. Basically, if the bracket is facing in the value. Oh, I see. So you're flipping the brackets. I see. Although, I mean, I wouldn't build it that way myself, but fine. Zaka6, welcome to the stream. No, I just want this syntax. This is something I built in a toy program language I made years ago. I actually could check ranges because this also enables me to do other things, but I like this. I don't want to have to put ampersands in. I mostly don't like this for range checking, but this is how Suki imagined it would go. X is an element of some range, except with the brackets flipping outward. See, I don't really think that's as readable to me. It also makes your syntax highlighting really hard, like your paren matching. Just a thought. Usual syntax is, yeah, 0 dot dot, yeah. That's how we learned intervals in math class. Okay. You also get with intervals if x is an element of 10 to 40 unioned with 50 plus infinity, blah, blah, blah. Okay. Yeah, I personally don't much care for this syntax, but it's your language, you do it your way. I like this code better. This is the way I will do it in my final language. Like I said, your language, you do it your way. I've not gotten into too many. I'm not too religious about mathematical syntax. Much more I care about the programming syntax. So I try to keep the syntax close to any other algol language in most of my efforts. The goal of the programming language was also to add math stuff. Yep. So like propositional logic and that sort of thing. Doing test permutations file. So where we generate our test file, I'm giving things like A through Z, int string. So an unexpected character could be a single quote in every encoding, and that would be fine. So let's go do that. See if we can add that as a test. I'm going to start with a decent test case. Contains unexpected character. Single quote is not defined in any of these, I think. So that should, and it would expect unexpected character. We expect 1 error and 0 warnings. We'll check the logs. We want to test this first, so we will break out after the first time through the loop. And that should be it. So let's run our test. You will be replaced with union, sure. So it would be 10 to 40, union 50 plus infinity. Yeah, I don't much care for that syntax, largely because matching flipped square braces is, oh, it failed. Shoot. Bracket matching doesn't work very well. Expected 1 error, got 0. I did kind of expect an error. The single quote I did not think was in. Let's see here. We have new line, white space, comment. Quotes, syntax. Yeah, none of this includes, in any encoding, has a single quote. So it should fail because of that. Well, okay. Unless I was silly. I didn't put my single quote after a comment, which means it was automatically discarded. Single quote before the comment. That will make it work better. So we're compiling our Tokenizer Generator, generating a configuration for it to test this build with ASCII, Latin, and UTF-8. There we go. So now we check our log. Error, unterminated token at the end of your text buffer cannot be accepted. So that was the expected error. We expect 1. Then here, UTF-8 state 0, unexpected character, single tick at line 116. Line 1, character 16. For UTF-8, that's probably right. One character, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 14, 15, 16. Yeah. Okay. I'm happy with that test. Now testing for unexpected characters. Now automated testing for unexpected characters. Not bad, that wasn't too bad. Actually, we can make it better. We should use another weird symbol. After ASCII, I don't think percent is supported anywhere. So it should be 2. We expect 2 errors. Just to see that it works. The goal of my language is to have an also unusual yet readable syntax. Oh, it's failing now. Caught the tick. It got an extra token. Did I? Is percent allowed? Oh, there's percent. I did pick one of the few things that we could. All right, let's take multiply then. Modulus with star. Okay. We expect 2, we get 2, and in our log we can see line 2, character 9. I don't actually want the error there. I want it. No, no. That's basically fine. Okay. Added a test for unexpected characters. All right. Why are we so short on time? We should do a file read. But before I do that, I've been really bad about plugging the old Discord. So I'll do that now. I do have a Discord if anybody wants notifications when I go online. It's really pretty quiet in there, so you're not going to get spammed just one day when I go online. So feel free to join up. We're building a Tokenizer Generator from scratch with no libraries, no dependencies. And we're building it every single way. So that we can measure the performance eventually. Because a lot of people have intuitions about performance that are wrong, and that includes me. So when we get done building the Tokenizer Generator, we're going to measure all these combinations of execution types for all these build options. So whether we implement certain functions as functions or as macros, whether we process things using std bind or lambdas. We're going to dispatch based on a switch statement, a function array, a function pointer, using gotos. They're all different. And we're going to measure whether like system call, library call, or the modern C++ file reading is faster. We're going to know how much performance we lose when we switch to UTF-8 to get those special characters. So a lot of different combinations we're going to have to test, which is what this testing script is all about. So we've got that. Got that committed. Test for file reading. Because right now we're not reading a file. Test.cbp writes out some text. So I think what we want is for our Python to output a file that can read, that can be read. Or not handwrite. For me, it's 700 lines total. Exactly. That's what I keep telling people. A tokenizer is not complicated. You should not build it this way at all. It's a for loop over the characters in a string. And each time you get a new character, you decide what state or what function to go to process it. So if you get an integer, like the number 1, you say, oh, I'm parsing an integer. You go to the parse integer function, and you just keep marching forward until you hit something that's not an integer. If you hit a dot, maybe you enter into the parse float function and capture the token and ship it off. Writing a tokenizer is not rocket science. That's the better way to do it. I'm doing this because it's a fun problem for me. I like going from regular expression pattern to NFA to DFA, so I can show what the DFA, some of this stuff looks like. Just a moment. Let me pull it up. Active projects, VV. Yeah, I'm doing this for fun, not because it's like a product I'm going to sell or anything. This is just education for fun. source. No, it's here. Let's open both of the. Oh, photos doesn't share. Let me open it in GIMP, then I'll share GIMP. Yeah, no, this is the worst way to do it. You don't write, especially if you want to ship something, you don't write every possible combination of build options you can think of. You pick one, you make it work. If you need to change it later, you do. You don't need to write a tokenizer generator. You either use an off-the-shelf one like Lex or Flex, or you just write your own tokenizer. It's not that hard. Where is open with? I don't have an open with option. Good heavens. There it is, GIMP. Good heavens. That takes a minute to come up. No, yeah, I'm doing this for fun. Doing it because I want to explore the ideas. And I have some, I think, unique ideas around using push-down finite autonomous that I haven't seen anywhere else. So I would like to explore those ideas a little bit. Okay, I've got both files open. Let me share the screen. Let's see here, Blender, Brave, GIMP, there it is. All right, here's GIMP. If I can get on the right window. So, given a configuration file, that's the DFA. So here's the, oh, come on. Where's the NFA? Did I open the wrong one? NFA open with. There we go. So here's the NFA. Fun. All of it's clear, easily understandable. Anybody could look at and understand this, right? It's actually not that hard. But then we take this mess and we turn it into something that's a little bit better. This is the DFA for the config file that I test against when I do the manual testing. When we do the automated testing, we're generating something much smaller than this, much more tuned for a specific encoding. But this one supports Russian, so this is the Cyrillic alphabet. This A is not the letter A, you and I know it's the A from Cyrillic. I thought we had other things in here that were, oh, here we go. Here's the Greek letters, right? This is alpha through, no, this is Russian. Where did the, oh, here we go, alpha through omega. So here's the Greek alphabet. That's not a letter A, and it's not an A from the Cyrillic alphabet. So we're doing a bunch of different things. So that's kind of where I'm starting to have fun in. And that all built out of this config file, test.vtok. Those two are from here. So here's your regular expression for Russian Cyrillic. Here's your regular expression for Greek alphabet. I'm testing escaped characters in my regular expressions here. It's not really that interesting, but another thing we do is backslash S. Let's see if I show the DFA again. When we say testing for white space, here's another thing we do automatically. GIMP. What the backslash S turns into here is actually, okay, I'm going to hide the thing again. Going to the code. Turns into NBSP. Into this. So we can check for space, tab, or if we're in UTF-8, we can check for non-breaking space. In my last job, multiple times people came to me and said, oh, the product's broken. And I took their configuration file, and it turns out that their YAML parser can't handle non-breaking spaces. So if you copy paste code off the internet into your YAML file, it just broke, and in horrible ways. Like, you did not know what to look for. It didn't make any sense. So when you say backslash S, we automatically assume you want to check for non-breaking spaces. Things like that. So I'm just playing around and having fun. Hopefully that answers your question. Yeah, no, tokenizers themselves are not hard. We're just playing. what we're probably going to do is after we get a good way along this thing, we'll pick one correct path for the way we want to implement it, and then we'll maybe do like a follow along, build your own compiler kind of thing. Not using Tokenizer Generator, just handwriting a tokenizer. Well, looks like Suki's in the Discord. Welcome, welcome. Okay. So, actually, we're probably going to have to start wrapping up. Let's see. We are locked in. Journals updated. Our to-do does have these 2 tests in it. I would like to get those done, but we're almost at 6 o'clock, so I got to get rolling. I have some steaks with my name on it that I got to go grill. And that takes precedence over testing file reading operations. Which does remind me, I need to make sure we do that, and then I'm pretty sure we rotate through this thing, and then yeah. So this won't add to our permutations. We're already walking through the file read operations in a reasonable fashion. The file read is the least coupled to any other piece of the process, so we don't have to test every build permutation. System file versus library file versus the modern C++ F streams. It'll get decent coverage just by rotating, not through a full. Because we could do for file read op in def defines for file IO. Like that's a whole nother permutation. We're just going to walk through it. That'll get plenty of coverage. When we go to measure performance at the end, then we'll need the full rotation, but not for testing. So yeah, I think we're looking pretty good. And next week, we're going to start implementing everything using gotos instead of functions to maintain our DFA states. So that's going to be fun. I started trying to introduce generics into my compiler today. Makes everything way harder and more annoying. Oh yeah, no kidding. AST syntax needs to change, which impacts everything. Yeah, I have not. So I've got this little toy language I've been playing around with over the years in different contexts. And I have not got to the point where I want to make anything generics for it yet. We're a long ways away from that in this build out anyways. So what language are you doing? Do you have like a Git repo, or is it for your own toy language, or personal language, I should say? Or is it, what's your thing? I'm always interested in other people's projects, look at their ideas, steal the good ones, or modify the ones that I'm like, oh, it's close, but is it like an algol-like or more of a functional language, or what's going on? Yeah, changing AST impacts everything. I have a repo, but there's no docs or anything to show. That's fine. I just like seeing what other people are doing. I find the world is broad enough that there are so many things I haven't heard of or that I've looked at and like discarded. I'm like, I'm not interested, but then somebody shows me something like, oh, that's why that's interesting. C-like systems language like Zig or Rust. Okay. Yeah, so I'm Monday through Thursday, I'm writing a game from scratch with no game engine, using only 4 or 5 dependencies, depending on how you count it. Once that project's done, I plan to do a small project with Zig. I don't much care for Rust. I would like to try Jai, but I haven't got on the beta list yet. Oh, you're pretty far in then. Nice. Yeah, I'd be curious to take a look, but I mean, not going to pressure anybody. Just say, if you shoot me a link, I'll take a look. It's fully usable, but no generics. Yeah, yeah. Yeah, generics can be very, very difficult. started writing a Vulkan renderer. Ooh, yep. Vulkan is I know some OpenGL these days, but I've not gone through the full process of getting Vulkan up and running in my own environment. Have need for dynamic arrays, which is not currently possible. Okay. Dynamic memory is tricky. Is all of memory management manual, or do you have some concept of garbage collection or reference counting or something along those lines? Because depending on that, that could make dynamic arrays more or less simple to implement on the compiler side. I mean that I need a generic dynamic array. Oh, gotcha. Yep. Else it's annoying to define it 10 times for each type. Yeah. For sure. Yeah. I mean, yeah, generics can be tricky. Well, there's different ways to approach it too, right? Like if you look at C, it basically said generics are you pass a void pointer and a function that takes that as a parameter, and then I'll do the right thing, like sorting. You'd have to pass your own comparison and maybe even your own like switch operator function. Or in C++, you've got templates, which literally just emit more copies of the same code every time you instantiate a new template implementation. It literally is just doing code copying and replacement. Then you go down the Java road, or I mean Python, you got your duck typing, but if you're doing a compiled language, which it sounds like you are, then you kind of have to be a little bit tighter on the typing, so duck typing doesn't work. So many options. All of them have their upsides and their downsides. Oftentimes the downsides is development time. Yeah, if you have a repo and you want to share it, let me know. We're taking a Rust-like approach. I will not copy-paste internal representation of the function art type. The backend should handle emitting different monomorphs. Okay. Parts of Rust I thought were quite good. Other parts of Rust I didn't like, so I'm probably not going back to it. But unless, obviously if somebody's willing to pay me, I'll go back to Rust. But for my own personal projects, I'm not putting myself through that learning curve any further than I already have. But I do want to try Zig and Odin and Jai in between projects. Hope I get on the Jai beta list. That would be nice. All right, well, I've got to go grill up some steaks. So thanks for joining along. I think we're going to be done with the Jai and Odin or somewhere. Yeah, there's some history there, I understand, too. But all good. Jai has more metaprogramming and compile time features. Yeah. That's one of the things that really excites me is like you can write code that modifies your AST or analyzes your AST for you. A lot of the times I'd like to set some like project rules of, hey, you're not allowed to modify these kinds of things from here, but there's no way to check it in the real world. But in Jai, you can. You just tag things and then say, hey, when you're running the compiler, if you see something tagged this, run this code. It's great. I think that would be amazing. Still closed beta. Yep. Yeah, it is still closed beta. I sent off an email requesting access not too long ago. I figured there's probably at least a 2-month lead time, and I'm not a big enough streamer that I would get any notice. So maybe he'd be looking and be like, oh, he's probably not going to look at it, but who knows? Maybe he'll give me access. Maybe he won't. But if he does, I'll stream it for sure. Yeah, I'll play with Odin, play with Zig. Those are easy to get my hands on. some things I really like about Zig too, so we will see who wins. Yeah, Jonathan Blow takes a while to get things done, but it's usually pretty high quality. Okay. Next week, we're going to start implementing gotos instead as an alternative to function pointers and function pointer arrays and functions for maintaining DFA state. It's going to be a wild ride. It's probably not going to be working for a while since we only work on it once a week. Like, it's really hard to get good momentum going. But that should be fun. A lot of people don't use gotos, and you can do some fun things with them. So join me next week for some game development, and then on Friday we'll pick up again. Hey, thanks for the follow. Zaka6. Yeah, so we're gonna wrap it up there. Feel free to jump in anytime. Game development Monday through Thursday, compiler on Friday as my vacation from the game development. And we'll catch you all later. Have a good weekend. Cheerio.